This is a questions in indices. Say 2 raised to power 2x plus 1 minus 5 bracket 2 raised to power x plus 2 is equal to 0. In a way to solve this, there is the first from the first law of indices is a raised to power m plus n can still be written as a raised to power m times a raised to power n. Therefore, the 2 raised to power 2x plus 1 is the same thing as 2 raised to power 2x times 2 raised to power 1, with the same thing as 2 brackets 2 raised to power x all squared. This can be written as this. In spite of continuation, in a way that you are writing the question 2 raised to power 2x plus 1 minus 5 onto 2 raised to power x plus 2 is equal to 0. So since you're able to rewrite this in another form like this, so therefore you have 2 onto 2 raised to power x all squared minus 5 raised to power 2x plus 2 is equal to 0. Let m is equal to 2 raised to power x. So we have 2m squared minus 5m plus 2 is equal to 0. So therefore the indices has formed an quadratic equation. Therefore, by the time you multiply these 2 and these 2, give you 4. So we have two numbers that you were able to multiply to give you 4, but by the time you add it together, it will give you minus 5. What are the numbers? Minus 1 times minus 4 will give you plus 4. Minus 1 plus minus 4 will give you minus 5. So therefore 2m squared minus m minus 4m plus 2 is equal to 0. So what common between these 2 is m. We have 2m minus 1. What's common between these two? 4m and 2. Minus 2 is common. Minus 2 is common. We have a minus 2 onto 2m minus 1 is equal to 0. What do you mean by common is, by the time you multiply this minus 2 with this, give you minus 4. Minus times minus 1 will give you plus 2. Therefore, we have m minus 2 onto 2m minus 1 is equal to 0. M minus 2 is equal to 0, or 2m minus 1 is equal to 0. So m is equal to 2, or 2m is equal to 1. So if m is equal to 2, or m is equal to, recall that 2m is equal to 1. So m will be 1 over 2. 1 over 2. But you are able to set your m to be 2 raised to power x. Since you're able to have said that 2 raised to power x is equal to 2, or 2 raised to power s is equal to 1 over 2. 2 raised to power s is equal to 2 raised to power 1, or 2 raised to power x is equal to 2 raised to power minus 1. Therefore, recall that if a raised to power m is equal to a raised to power n, m will be equal to n since they have the same base. Therefore, 2 raised to power s is equal to 2 raised to power 1, or 2 raised to power x is equal to 2 raised to power minus 1. So s is equal to 1, or s is equal to minus 1. Thanks for watching.